So my name is Dennis Hamann. I'm the Chief Commercial Officer for a new entity called the Future Mobility Campus Ireland. We'll go through that here in a second.
Yeah, so my name is Florian. As you can see, I'm a Red Hat employee. So I worked for Red Hat for the past 2 years as a solution architect, working very closely with our automotive customers in Ireland and FMCI as a kind of greenfield project, which is much more interesting.
This just gives an overview of the campus, and then we'll go through the slides afterwards. So.
Okay.
That's great. Thanks, Diane. If you want to just pull up the first slide, I think we can just go.
All right, I'm going to try that again. And Windows.
Yeah, I have the slides on.
Well, awesome.
Great. So why don't I kick it off then? So what you just saw was actually a digital rendering of the facility at the Future Mobility Campus Ireland. Actually, the campus itself has been operational and functional since September, October of last year. We've just been operating out of temporary facilities, but we actually just moved into that control center building, which you saw as part of the video about 3 weeks ago. And the grand opening will take place in end of May and June of this year. And so I suspect this session is going to be a little bit different from the other ones you'll see today in that we're kind of a unique entity. We're really an entity that's a collaboration of, I'd say, 3 parties. There's a bunch of technologically oriented multinational corporations, one of them being Red Hat, of course. There's government entities involved in this, like Enterprise Ireland, and local and both the local and regional and national level for Ireland. And then there's a whole startup ecosystem as well that forms kind of the third leg of the stool for the whole campus. And basically what our goal is to, as the name implies, future mobility campus, the really development and facilitation of future mobility technologies. So let's go in specifically into some of the specific use cases on the automotive side, and then I'll turn it over to Florian after that for the first one. So if you think about, in general, what is our value added? In a nutshell, I would say it's the harvesting of rich data. I mean, in essence, what happens is all of our partners, collaborators, customers come to us, and they come to us typically with a problem. And it's a problem that's usually embedded in the idea of what they can do to enable much more rapid development of future mobility technologies. And what they expect from us is to work with them in various testing scenarios and so forth to help to solve that problem, get them the information they really need to make the best decisions. And the scope actually goes beyond just the campus. The campus itself, which you saw the video on, is important, and that's really kind of the heart of the test bed. But we would like to think that it's really Ireland itself is really our entire test bed, because the infrastructure that we've built actually extends into the motorway system of Ireland itself. There's actually 450 kilometers of connected highways with fiber that will home the next version of V2X technology, CV2X and ITS-GS and so forth. So really our testing starts in kind of a lab environment, in a very controlled environment, and then goes much beyond that to facilitate the needs of our customers. So go to the next slide. One more back. Thanks. So let's talk about the automotive specific use cases in the next slide. There we go. There's a couple of key areas that are interrelated yet separate. So first of all, we actually operate our own dedicated fleet of vehicles, connected autonomous vehicles, currently at a number of 5, which includes 2 Jaguar I-Paces, one Land Rover Defender, 2 Teslas, and a lot more coming soon. And those range from very R&D oriented types of vehicles, such as the top picture you see, which is equipped with, heavy duty compute and data logging equipment, enhanced LiDAR, radar, and so forth, to actually production vehicles. So that's one set of our infrastructure. But the other is a whole available IT infrastructure that is really designed to not only support those vehicles, but support any vehicles that actually come to use the facility. So it's really hardware agnostic or vehicle agnostic, with high-speed data ingest stations. And that couples with an on-prem data center. There's a whole set of Cisco roads and smart city infrastructure also on the campus, and then a whole public and private cloud connectivity. And in essence, what the use cases are the ones that you see there on the right. It's basically for OEMs, for component manufacturers, for startups, really to come with specific use cases where they're trying to solve problems and accelerate their development intentions. So if you look at the next slide, the overall specific kind of goal that we're trying to reach here is basically an end-to-end closed loop data platform, and it's the one very similar to what Tesla has really pioneered on a much more production level. So it's really the idea of a set of vehicles that start all the way from the R&D sense, and then can extend all the way through pre-production and ultimately series production vehicles that always provide a rich repository for harvesting more and more data and improving product better and better over time. That's really what it's all about. So if we go to the next slide, how do we do that? I'll show you just a couple screenshots of the kind of software solution that's overriding this whole thing. So first of all, there's an overall control center data orchestration solution that talks to each one of these vehicles and in real time is gathering not only telemetry data, CAN data, but then unstructured data, blob data, video data, LiDAR, radar, and so forth. So you can imagine there's quite a bit of data that gets harvested from these vehicles in the nature of 2 terabytes per hour. So what becomes very important is not only to get the data, but intelligently be able to do things as close to the point of collection as possible, to get the most salient data harvested and to the right people in the most important way possible. So you notice the lower right-hand corner of the screen there, you see workloads. And that's really an important concept, is that basically, and where Red Hat plays a role with us, is how do we actually pre-program workloads and queries to where we can get the most important data as quickly as possible, then send that where it needs to go. So if you look at the next screen, here's an example of the kind of queries that we would set up, for example, to where, say, an ADAS developer in Stuttgart is looking to run test data, but they want to see all the times there's an automatic cruise control disengagement with a hard braking event and so forth. So we can actually harvest that in real time and get those snippets of data to them as quickly as possible, so they don't have to wait what has typically been the case of days or even weeks to get all of the bulk data, which then needs to be processed and screened and everything in order to get that kind of information. So that's a really important point of what we try and do. And in the next slide specifically here, I know that we're talking automotive here. That's the most important part that we're focused on, where we spent the bulk of our time of late. But this is exactly the same issue that we're going to face in advanced air mobility as well. So all the same problems of vehicle data, varying levels of autonomy, and in this case, in moving not only people but freight across air taxi routes and drone flights and whatever, will be replicated in the advanced air mobility side as well. And the same data orchestration thing and package and platform that we're talking about is actually what we're implementing to cover both air and ground. So if you go to the next slide, in essence, what we've built and continue to develop on is a complete service delivery platform. And you can see kind of the depiction here of it, kind of the 8 levels of architecture that we work on. And it starts very much at the bottom level of the exact interaction with the data capture sensors, and goes all the way through processing levels at the edge, then application simulation workloads into data repositories, and all the way up the chain to a multi-tenanted model for our customers and our partners, which actually allows them to query and manage that data in a very efficient way, but then ultimately even becomes a marketing tool that we use to sell our services to other people as well. So you see where OpenHat or Red Hat OpenShift really plays a key role, and it's in the last 3 or 4 areas of the model here. And so what I'm going to do is turn it over to Florian now, who can kind of go through the details in a bit more detail about kind of where OpenShift really plays a part there.
Thanks for that, Dennis. So first of all, this project has been really great, right? So usually I get to work on all the boring stuff that we do in Red Hat, which is data center work for large organizations. So working on this was really exciting because we had something completely new, greenfield, right? And there's no data center, there's no servers in the room, there's no nothing. So going into this was really interesting because we really had to, a blank sheet and think from there. So I want to start on the right side maybe, and on the bottom right, because where we're really starting as a foundation for all of us to make this happen, as with everything, is a data center, right? We need extremely fast storage, we need extremely fast compute, and we need a well-established networking, right? So we work with a bunch of partners, Cisco, Seagate, Red Hat, and a bunch of other partners that kind of sit somewhere in the middle to make this happen. So the platform that we designed was really all around making sure that we have, first of all, a virtual data center, right? There was no point, not going, as we say, cloud native, but, you don't have to be in the cloud for that. We went in the data center locally to begin with. So we just stood up a bunch of servers, essentially, and leveraged OpenShift as a platform where we can onboard and utilize as many partners as we want. So you need to think about this, that, tomorrow there could be university or MIT coming in and saying, oh, this is great. We would like to engage with you. We would like to try this out. And then the question is, how do we onboard them? How do we make application space to them available and compute space and resources, and make sure that then they can interact with our other partners? And, obviously no one wants to go in and think about infrastructure. So by us abstracting from that level and providing, I suppose, a compute platform, which is built around OpenShift, really just allows everyone to just get started very, very quickly on this platform and also interact with each other. Because from a technical side, you obviously have all the benefits of a Kubernetes platform, right? And in that case, OpenShift, to be able to interact throughout multiple namespaces, make data available, control networking, ingress and egress. And that way, we really designed a platform that from the ground up was meant to be inclusive. And, inclusive, I mean, for people that come from academia, for people that come from commercial side, and people that maybe have different interests in it, like alternative partners, someone like Seagate who provides a different platform, or Renovo, or whomever might be, in that space to collaborate with us. And then the idea is then that on top of it, we're providing a trusted software factory. So the next question is, right, so we provide a platform, but how are we building applications, that we're going to bring into the car? And here we started thinking about, what is this platform going to look like, right? How can we make sure that, the containers that we build and the images are secured? How are we making sure no malware is being introduced? And what we've done is we've built basically a blueprint, CI/CD platform where everyone can come in, use this as a blueprint and enhance it, tailor it towards their needs. But we can really make sure that we provide this out of a box for other partners that are going to be working with us. So this is currently what we're working on. The servers were delivered a couple of weeks ago, and we really started thinking about that right now. And then for us, I only have a minute left. The next step in the next 12 to 18 months is really how are we going to be able to move, the not just OpenShift, but the Red Hat and the new operating system for the car that is going to be running Linux. How are we going to be able to move this into the in-vehicle and integrating it with a platform? So far, what we've been able to do is deploy the platform, make sure it's inclusive. It's going to be able to run all the workloads that we need. And now the next step that we're going to do is think about how are we bringing this to the edge and to the actual edge device. So this is really interesting because obviously we're leaving a little bit our comfort zone, right? The right thing, we know somewhat how to do that. We have some experience with that. And the interesting challenge here was to design it for a new blueprint and for a new greenfield kind of project. But now the next challenge is really going to be how are we going to be able to bring the Linux OS in the car and going to be able to move applications from the right side into the left side. So I'm really looking forward to work with Dennis and the FMCI team, to work with them over the next 12 to 18 months to make this happen. And, Dennis, I'm sure you would say it as well, but I'm going to say it as well. If you're in that space, right, please engage with FMCI, right? So it's an open project, it's collaborative, everyone can participate. All you need to do is basically show up in Shannon, with a backpack and a couple of drones or a couple of cars, plug in, and you can basically use that campus. And that's really the idea behind it, that as many partners, customers, academia, and whomever out there is going to be able to make use of that. So I'm not sure, Dennis, if you want to add anything to it, but I think it's just worth.
That's exactly right, Florian, and thank you for reiterating that. It's really meant to be an open collaboration, and we've chosen top shelf partners such as Red Hat to be a part of this, but others we've mentioned such as Seagate, such as Jaguar, such as Cisco, which are clearly a part of this. And it's really to have the infrastructure available and open and ready to be used in a lot of different ways and innovative ways. So it's really all about acceleration of your programs. If you're a startup, if you're a multinational technology provider, or if you're a government entity or smart city, that's really what we're all about. So we encourage your involvement. You can contact me directly. Of course, you can show up in Shannon at any time, and we'd love to talk to you.
All right. Well, I am bringing my drone to Ireland with me this summer when we host the Dublin OpenShift Commons gathering. You better watch out. I did get my Canadian drone license, so I could be dangerous here.